In this session, we will start from discussing about the adjoint matrix. Adjoint matrix is again said to be a matrix which can be considered as the transpose of the matrix including cofactors. Therefore, they are when we are discussing about the matrices, there is a concept called cofactors. And if you are writing the cofactors inside the matrix, and if you take the transpose of that matrix, then such matrix is said to be adjoint matrix. Prior to discuss about this adjoint matrix, first we need to have an idea regarding the cofactors. It is because we have not discussed about the cofactors so far. Then first we will see how we can define and obtain the cofactors if the matrix is given, and then we'll see how we can use the how we can obtain the adjoint matrix based on the cofactor values that we have obtained. When we are going to discuss about cofactors, there is another important technique called obtaining minors. If you consider about minors, suppose that if you have given a square matrix, only for the square matrices, we are defining these concepts. We are not going to just interested about any given rectangular array of numbers. Therefore, we will consider that A is a square matrix, and suppose that this square matrix, suppose that if A is a square matrix, suppose this has n number of columns and n number of rows, likewise, then you may have entries here A11, A12, likewise, you may have these values. Likewise, n. Therefore, this can be considered as n by n square matrix. But here, what we are going to identify is we are going to identify the minors. When you are going to identify the minors, you have to obtain the minors for each and every given entry. Suppose that if you are having, if A is a 3 by 3 matrix, then there will be 9 elements. There will be 9 elements in this matrix. If you are having 9 elements, then there should be 9 cofactors. If there are 9 elements, then there should be 9 cofactors. Therefore, if you have given any square matrix, the cofactors that you have to obtain is equal to the number of elements or number of entries in the given matrix. Since we are denoting these elements using the notation Aij, we are first, prior to starting this part, I will discuss this part as well. If you are having 9 elements, you have 9 cofactors, therefore, you must have 9 minors. So number of cofactors equal to number of minors equal to number of elements given in the square matrix. And if you are going to find out or naming these minors, then we have to follow this notation. Generally, we are using the notation Aij notation. This is to denote elements or entries in a matrix, and then we are using Mij. Here this Mij, you can use uppercase letter M or lowercase letter. This Mij stands for the minor that we are obtaining. Then using these minors, we are going to identify the cofactors. Since we are having this Ij number of minors, then there should be Ij number of cofactors as well. Then we have to use this notation to denote the cofactors. Once you have an idea or once you have obtained the minors, then using this equation, you can easily obtain the cofactor values. Therefore, to obtain the cofactors, what you can use is Cij equals minus 1 to the power I plus j times m ij. This is the rule that we need to follow, but we are not interested in using this equation on obtaining minus. Apart from using this equation, we are tempted to use the sign patterns which have defined for each given type of matrices, but actually the sign pattern is obtained using the concept called this minus I to the minus 1 to the power I plus j, minus 1 to the power I plus j. Using this concept, actually the sign pattern has sign pattern is actually based on this quantity minus 1 to the power I plus j. Therefore, if you are combining the sign pattern with minus, then you can easily obtain the cofactors for any given matrix. Therefore, first we will see how we can obtain the minus, and then we will discuss how to obtain the cofactors by combining the sign pattern with minus. When I'm discussing about obtaining the minus and cofactors, I told that the number of minus equal to number of cofactors equal to number of elements in the given matrix. Suppose that we are having a matrix called matrix A, having the elements A1, B1, C1, C3. Here we are having A3, B3. Suppose that this is the matrix we have given for us. If you have considered a single element, suppose that here we are considering the element A1. Suppose that we are taking this element. If you have considered this element as A1, now what you have to do is to obtain the minor associated with this A1, you have to first cut down the row and column associated with this given value. Then you can see that the remaining part, it is B2, C2, B3, C3. Then you have to take the determinant of this quantity. Then what you can do is to identify minor of A1, to identify minor of A1. Minor of A1 can be obtained using the determinant of the remaining elements. It is B2, C2, B3 and C3. Once you take the determinant of this quantity, then you will get this as B2, C3 minus B3, C2. Therefore, to obtain the minor for each and every element given in the matrix, what you have to do is first you have to cut off the row and column associated with the element selected, and then you have to take the determinant of the remaining elements. If I take another example for this, suppose that I am selecting suppose that I am selecting the next element as C2. Okay, I will take this as B2. Okay, if I take my next element as B2, then what I have to do here is first I need to cut down the row and column associated with the selected element. Then we have to take the modulus of the remaining elements. Then this can be considered as, here it is, minor of B1. So it is minor of B2 can be obtained by taking the modulus of this A1 C1 A3. Therefore, we can take this as A1 times C3 minus A3 times C1. Then using this concept, you can easily obtain the minus for given star. Since we are having 9 elements in this matrix, then we should be able to obtain 9 minus for this given matrix. Here I have taken only 2. Therefore, you can take minor of 1, minor for A1, minor for B1, minor for C1, minor for A2, likewise minor for C3 as well. Using this concept, you can obtain the minus, and I told you that we can obtain the cofactors Cij. This equals minus 1 to the power I plus j times Mij. Now we know how to identify the minus if you have given a 3 by 3 matrix. Then here we need to pay our attention regarding sign pattern. Actually, instead of this minus 1 to the power I plus j, what I can take is I can consider the sign pattern instead of this quantity. It is because actually the sign pattern or the sign patterns are based on this concept. If you see about the first matrix, you are having now we have to focus on the sign pattern, how to obtain this sign pattern for given matrix. Now we can see that the sign pattern is given here. It is given for 3 by 3 matrix and 4 by 4 matrix. If you consider about this for 3 by 3 matrix in this session, we will discuss this only for 3 by 3 matrix only. If you consider this 3 by 3 matrix, then we can consider the sign pattern as plus, minus, and plus. This is always starting from the plus sign. As I mentioned, we have to start the sign pattern always from a plus sign. Then next sign would be always opposite sign to the sign that you have previously written. If I written all these things again, first starting from plus sign, then next one would be minus sign. It is opposite to this. Then the next sign should be opposite to the sign that I have written previously. It is now again this opposite to this minus, then this would be equal to plus. Then we have to write the next sign opposite to this plus sign, exactly right down here. Then you have to come in this way around, then this would be plus, then it will be minus. Then again the opposite sign, minus and plus. Therefore, this would be considered as the sign pattern for a 3 by 3 matrix. Here the same is given for 4 by 4 matrix as well, but you can be familiar with that. The only thing is starting from always opposite sign, and then you are going it in this way around. Always this pattern is there. And if you see for 4 by 4 matrix, now consider this side is given as 4 by 4 matrix. And you can see that the sign pattern starts from plus, then minus, again plus, again minus. Then you have to start it from here. It would be given in this way. Therefore, what we can see here is we have started from this point and then came around this way. Likewise, we have continued this. Therefore, this is how we are identifying the sign pattern for a 4 by 4 matrix. But here I will not going to discuss obtaining minus and cofactors for this what we can say as obtaining minus and cofactors for 4 by 4 matrix. I will discuss about obtaining minus and cofactors for 3 by 3 matrix only. Now, if you consider about this combining minus with the sign pattern to obtain the cofactors, then we can use it in this way. As we have used the notation Mij. We have previously used the notation Mij to denote the minus for a given matrix. Then we have to combine this with sign pattern. First, we can write down all the minus as given this way. Here it is M11, then M12, M13. Previously, we have discussed how to calculate the minus. Here, this would be M31, 32, M3. Here, we have now what we have to do is now we have to combine these minus with sign pattern. Therefore, if I write down the sign pattern in the appropriate places here, this sign should be plus, then this value should be multiplied with minus, this should be multiplied with plus. Similarly, we can write down the sign pattern for this rest of these elements or rest of the minus. Then once you write down or once you combine the minus with the sign pattern, then you can obtain the matrix which we are calling as the cofactors. Then this would be equal to the matrix including the cofactors. Therefore, even though you are using this equation Cij equals minus 1 to the power I plus j Mij, you are getting the same result as this. You may get the same result as this. Therefore, this is how we can obtain the cofactors by combining the minus with the sign pattern. For a 4 by 4 matrix also it is given, but I am not going to discuss it under this session. Then I will directly move for discussing an example. Related to 3 by 3 matrix. First we will see this. Here we are having a matrix given as matrix A. Matrix A is given as 0, 2, 1, 3, minus 1, 2, 4, 0, and 1. Here, this is the form, this is the matrix given for us. This is a 3 by 3 matrix. First, if you ask to find out, now we'll directly move for, first we'll move for obtaining the minus for this given matrix. Now you can see that there are 9 elements in this matrix. Therefore, see, since we are having 9 elements in this matrix, there should be 9 elements, 9 minus should be there. Then first I will name these 9 minus as M11. Then I will write this M12, M13, M21, M22, M23, then M31, M32, and M33. Now we need to identify all these 9 minus. Therefore, what we have to do is we have to consider the concept that we have used previously. First, what we need to do is First, we need to identify the first element or the element in first row, first column. Then cut down the row and column. Now we have cut down the row and column associated with the first row, first column element, and then I have to write down the remaining elements in this matrix after cutting down the row and column. Therefore, I can write down the elements inside the modulus notation. Here this would be -1, 2, 0, and 1. Now if I perform this calculation, I will get this as -1 into 1 is -1 minus 0. It is because 0 times 2 gives the value as 0. Therefore, I have obtained, I will write these values separately for the clearness of the calculation. M11 has obtained as -1. Then what we can do now is we can now go for the obtaining the -4. First row, second column element. First row, second column element. Here we have to cut down the first row and the second column. Once you cut down the first row and second column, then the remaining elements are written in the modulus notation to take the determinant 3 and 2, 4 and 1. Once you take the difference of the product of diagonal elements, then this will be equal to 3 times 1 minus 4 times 2. It is 8. Then this value will be equal to -5. If I take this value here, then this would be equal to M12. This equals to -5. Similarly, if I repeat the same procedure for the next one, it is for M13. Element in the first row, third column. You have to cut down the row and column associated with the element that you have considered. Then we have to take the determinant of the remaining elements. Then this can be written in this way: 3 minus 1, 4 and 0. Taking the difference of the diagonal products of the diagonal elements. 3 times 0, 3 minus 4 times -1 minus 4. Results the value as +4. Then we can take this value as M13 as +4. Similarly, we can obtain the values for the remaining elements also. Since we have finished the first row, now we can move for the second row. As the starting element of second row, we can get it in this way. Now, cut down the first column and second row since we have considered the element in second row, first column. Then remaining elements can be written in 2, 1, 0 and 1. This equals to 2 minus 0 equals to, therefore we can take M21 equals. Then by using the or repeating the same concept for obtaining the minus, we can obtain the minus for the remaining elements as well. If I directly write down the calculation steps, M22, then cut down second row with second column. Elements will be 0, 1, 4 and 1. Use the value as 0 minus 4 is equal to -4. M22 is -4. Then M23, second row, cut down with third column, second row and third column. Then values are 0, 2 and 4, 0. Then 0 minus 8 value becomes -8. M23 is -8. Then for the M31, third row with first column, values will be 2, 1, minus 1, 2, then 4 minus 1, value is 4, and 3, 1 equals 5. Similarly, M32, third row and second column cuts off, 0, 1, 3 and 2 is taken. Then taking the cross multiplication, 0 minus 3 equals to minus 3. M32 equals minus 3. Then M33, third row has to be cut off, third column has to be cut off, then 0, 2, 3 and minus 1. 0 into minus 1, 0 minus 3 into 2, 6 equal as minus 6. Then M33 equals minus 6. Using this technique, we can obtain these 9 minus, and here also you can see that the minus obtained for this calculation. Now what we can do is we can now combine the sign pattern with these minus. To obtain the cofactors, we have to combine the sign pattern. Therefore, if I write down the cofactors here, I can obtain the cofactors in this form. Here, starting from C11, C12, C13. First, I will write down all these things and then I will go for calculation. It is C21, C22, C23. Now what we have to do is we have to combine the sign pattern with the minus that we have obtained. The sign pattern for 3 by 3 matrix is given as plus minus plus. We are having this format. Therefore, first I will write down the notation. Here we are having plus sign, minus, plus, minus, plus, minus, plus, minus, and plus. Then we have to write down the minus that we have obtained. The first minor or the minor for the element in first row, first column was obtained as minus 1. Here we are writing the minor that we have obtained. Then it has to be multiplied with the sign which is given under the sign pattern. Then next value is minus 5, plus 4, plus 2, minus 4, minus 8, plus 5, minus 3, minus 6. Therefore, the calculation gives us the value minus 1 plus 5, 4, minus 2, minus 4, plus 8, plus 5, plus 3, and it says minus 6. Therefore, these can be considered as the cofactors for this given matrix. Now you can see that these are the cofactors. To obtain the cofactors, what we have done was we have combined the minus with the sign pattern. By combining these minus with sign pattern, these 9 cofactors was obtained. Now you know that if you move back to the how defining the adjoint matrix. Adjoint matrix is said to be the transpose of the matrix, including cofactors. Transpose of the matrix, including cofactors. Now we have identified the cofactors. Then what we can do is to obtain the adjoint matrix. First, we can take we can write down these cofactors inside the matrix, and then we can take the transpose of that matrix. Then if I write down the matrix including cofactors, then I will get this as The matrix including cofactors will be quite similar in this form. It is -1, 5 and 4, -2, -4 and 8, -5, 3 and minus. This will be the matrix including cofactors. But what we need to obtain is we need to obtain the adjoint matrix. Therefore, what we have to do is we have to take the transpose of this matrix. Therefore, we can say that adjoint matrix of A. We are denoting it as ADJ. Adjoint matrix as of A can be considered as the transpose of the matrix including cofactors. These are the cofactors that we have obtained. Then we have to take the transpose of this matrix. Once we get the transpose of this matrix, then we will get the values in this way. First row becomes first column. Here this is +5 actually. Just because we have obtained +5 here, it should be +5. Then this transpose of this matrix would be -1, 5 and 4. Then this would be -2, -4 and 8. Then +5, 3 and -6. Therefore, this can be considered as the adjoint matrix of 8 is because we have taken the transpose of this matrix including cofactors. Therefore, this is how we are obtaining the adjoint matrix, and here an exercise is given for you to obtain the minus and cofactors for the given matrix B. The matrix B is given as a 3 by 3 matrix. Then you need to find out the adjoint matrix for matrix B. If I brief about this calculation, first what you need to do is first you need to obtain the minus. Then you need to write down the sign pattern. By combining the minus with sign pattern, you can obtain cofactors. Then you can write down the cofactors and inside the matrix, and you have to get the transpose of the matrix including cofactors. This is how we are defining, these are the steps of obtaining the adjoint matrix for a given square matrix. Now we will move for another concept included or have to discuss under these matrices. Now we will move for discussing about the inverse of a matrix. Here also we are defining the inverse for square matrices. Suppose that A is n by n square matrix, and suppose that I is an identity matrix having the order n. Let A be this n by n square matrix and I be the identity matrix of order n. And we are saying that there exists a matrix called as A inverse. There is a matrix called A inverse as it satisfies this equality A times A inverse equals I. If the product of any given two matrices gives an identity matrix, then it can be considered that one matrix is an inverse of the next matrix. Therefore, once you multiplied a matrix with its inverse, then you will get an identity matrix. Based on this concept, now we can prove this as well. If you multiply this A with A inverse, this would be equal to A inverse times A. It means that the order is not necessary here. In generally, we know that if you are multiplying AB with BA, these are not equal quantities. When we are discussing about the matrix multiplication, we have identified this inequality. But once we consider about this inverse matrix, then we can say that these two quantities are equal. Therefore, if you can see two matrices, suppose that AB equals this BA, then we have to say that B is the A inverse. B is equal to A inverse. Generally, this thing happens. Therefore, once you multiply this, this would be equal to I as well. Since you have observed that A is a n by n matrix and I is an identity matrix having order n, then A inverse also should be an square matrix having the order n by n. Therefore, A inverse, we are using this notation. We cannot say that it is A to the power minus 1. We are not saying it in that way. We are pronouncing this notation as A inverse. Therefore, A inverse also having the same order as A. And we are saying this as inverse of A. And now we'll see how we can find an inverse for a given matrix. We'll see how to calculate inverse for a given matrix. To find the inverse for a matrix, if it is a 2 by 2 matrix, again we are using a different method, somewhat a simple method compared to obtaining inverse for 3 by 3 method. Suppose that if you are having, if you are going to find out the inverse of matrix, then this thing we have to pay our attention on these things as well. When we are finding inverse of a matrix, some matrices does not have an inverse. If a matrix has an inverse, then we are calling such matrices as non-singular matrices. Or we are saying that matrix A is invertible. If a matrix has no inverse, sometimes when we are defining or when we are discussing about the concept of these calculation steps of obtaining the inverse of matrix, then we may you may learn how we can identify whether the inverse exists or not. If you can see that, if you cannot see that, or if you cannot obtain that the matrix does not have any inverse, and simply matrix does not have any inverse, then we are saying such matrices as singular matrices, or we are saying such as non-invertible matrices. Therefore, if A inverse exists, then we are calling such matrices as non-singular matrices, or we are saying this as invertible. We are saying these matrices as invertible. If A inverse does not exist, then we are calling such matrices as singular matrices, or we are saying them as non-invertible matrices. We are saying such as non-invertible matrices. Now we will discuss an example related to 2 by 2 matrix first, and then we'll take an example related to 3 by 3 matrix. But without discussing about this simple method for 2 by 2 matrix, I will first discuss about how to use this equality, or based on using the definition, how we can identify an inverse for a given matrix. Suppose that matrix A is given. Here the calculation is shown. Suppose that matrix A is given as 1, 4, -1 and -3, which is a 2 by 2 matrix. Then it is according to the definition, it is given that A times A inverse equal to I. Now here you can see that A is a 2 by 2 matrix. Therefore, A inverse should be a 2 by 2 matrix, and I should be an identity matrix having order 2. Then what we can see here, what we can take here is, here we can take, since A is a 2 by 2 matrix, then we have to take this I2. I2 should be a 2 by 2 matrix. 1, 0, 0 and 1. This should be a 2 by 2 identity matrix. Okay, if you continue with this, here we are having I2 as an identity matrix, which is a 2 by 2 matrix. Then we can write it in this form. Here I have told you that A is a 2 by 2 matrix, and I2, or this can be considered as this identity matrix is order 2. Then we know that A inverse should be also a matrix having the dimensions 2 by 2. Since we know that the dimension of this inverse matrix is also 2 by 2, then we can write this matrix, since we do not know, still we do not know what are the elements of this A inverse matrix. Therefore, first we will say that A inverse is equal to a matrix having 4 elements, A, B, C and D, 2 by 2 matrix. Then what we can take here is matrix A is 1, 4, -1 and -3. Now we have identified that A inverse is also 2 by 2 matrix. Here it is A, B, C and D. Then this is equal to an identity matrix having order 2. Now what you can do is, first we can solve the left hand side of this equation. If you multiply these two matrices, then what you can obtain is the quantity which is obtained is included here, and this can be now considered as two equal matrices. Therefore, using the concept of two equal matrices, we can easily obtain the inverse, simply obtain the values for A, B, C and D. Therefore, what we can do is, first we can equate these corresponding elements. Then we'll get this as A plus 4C, A plus 4 times C equals 1, B plus 4 times D equals 0, minus A times minus 3C equals 1, and minus B times minus 3D equals, here this should be 0 and this should be 1. Now what we can do is, here we can see that 4 linear simultaneous equations, and we are having 4 unknown variables. Now solving these 4 simultaneous linear simultaneous equations, we can identify what are the values for A, B, C and D. If you are performing this calculation, then you can see these are the values what I have obtained. Solving these 4 equations, the obtained values were A equals minus 3, B equals minus 4, C equals 1, and D equals 1. Therefore, now we can include these four values inside the inverse matrix. Then we can say that A inverse is equals to A, B, C, and D in the order given. A, B, C, and D. Here it is a 2 by 2 matrix. Therefore, this is how we are obtaining the inverse for a given matrix using the definition. But when we are going to obtain the inverse for a 2 by 2 matrix, now you can see that here we have four unknown constants. We need to find the values for four unknown terms using four equations. But here I have not discussed about how to do this calculation. But if you are try to perform this calculation, it will be somewhat time consuming calculation. But now think about if it is given for a 3 by 3 matrix. Suppose that B is given as a 3 by 3 matrix. Then we can identify that B inverse should be a 3 by 3 matrix having elements as A, B, C. I will take X, Y, Z and P, Q, R. Now you can see that there are altogether 9 unknown constants we need to identify. We need to identify the values for these 9 terms. Then what we can do is we have to define 9 linear simultaneous equation. It will not be easy for doing such a calculation. Therefore, we are trying to use alternative methods to identify the inverse for a 2 by 2 and 3 by 3 matrices. Here I am not going to discuss about any square matrices beyond 3 by 3 of obtaining inverse for a given matrix. Therefore, since we can see that this is somewhat a lengthy calculation and it is a time consuming calculation, therefore we will go for an alternative methods. If you discuss, if you see this for 2 by 2 matrix, suppose that matrix A is given as A, B, C, and D, which is a 2 by 2 matrix. If you need to obtain the inverse of this matrix, suppose that you are asked to find out the inverse of this given matrix. The first step what you have to do is you have to check whether A inverse exists or not. A inverse exists or not. To check whether this inverse matrix exists or not, what you have to check is you have to check for the determinant of this matrix. If the determinant of the matrix is equal to 0, if the determinant of the matrix is equal to 0, then we are saying that A inverse does not exist. A inverse does not exist, and at this point we can terminate the calculation as. But if it suggests that the module this determinant of A is not equal to 0, then we can say that A inverse exists, and then we can move for the calculation of A inverse. If A inverse does not exist, then we are terminating calculation. But if this A inverse exists, it means that determinant of A does not equal to 0, then we have to move for the second step of this calculation. To get the inverse for a 2 by 2 matrix, then you can use this equation. Here we can take this as A inverse. This equals to 1 divided by AD minus BC Here simply we can say that it is the reciprocal of the determinant of the matrix. Here we can say that if here we can see that this notation, the determinant of this matrix A is given as AD minus BC, since we can see that the values are in the way which gives the determinant as AD minus BC. Then this has to be multiplied with the matrix having the elements A and D are now interchanged. Therefore, D comes here and A goes here. And then B and C, we are not going to interchange the places, but we are multiplying these with minus signs. Then this would be minus B and minus C. Therefore, using this equation, you can obtain the inverse of the matrix. Now you can see that why we are saying that if A equals 0, A inverse does not exist. It is because once we are getting this A equals this determinant of A equals 0, then we can see that this quantity will become 0. Therefore, if we are getting this 1 divided by 0, this can be considered as the indeterminate form in mathematics. This goes to infinity. Therefore, 1 divided by 0 goes to infinity. Therefore, we can say that A inverse does not exist. That is why we are saying that if this modulus of if the determinant of A does not equals 0, then we are saying that A inverse does not exist. But the determinant of A does not equals to 0, we are saying that A inverse exists. Therefore, if you can, first you need to find out whether A inverse exists or not. Otherwise, at the end of calculation, you may understand that A inverse does not exist. That is why at the very beginning, I explained that some matrices have an inverse and some do not have. And this method is valid for only for 2 by 2 matrices, and we can extend this method to calculate the inverse for 3 by 3 matrix as well. Now, if you consider an example related to obtaining inverse for 2 by 2 matrix, first I will take matrix A. Here it is given as 3 minus 1 minus 2 and here if it is asked to find out A inverse, suppose that you are asked to find the value for A inverse or the matrix for A inverse. First you need to check whether the inverse exists or not. To check whether the inverse exists or not, first you need to take the determinant of this matrix. To take the determinant, what you can do is you can take the difference of the product of the diagonal elements, then this will be equal to 3 times 2 minus 1 times minus 2. Minus 1 times minus 2 gives the value as plus 2, then this equals to plus 4. Now you can say that since the the determinant of A does not equals to 0, we can say that A inverse exists. A inverse exists. Since A inverse exists, now we have to move for the calculation of A inverse. To calculate A inverse, we can use this equation. We can calculate the A inverse using A inverse equals 1 over, instead of this AD minus BC, I can write it as determinant of A. It is because now we know that if the matrix is given in this form, A, B, C, and D, if it is given in this form, we know that the determinant of this actually determinant of the matrix is given as AD minus BC. There is one correction I would like to take at this point. Here it is not the modular sign, it is just the AD minus BC. Using this equation, we can take this, please correct this. This should be AD minus BC, not there is no any modulus. If you are using a modulus sign here, but here we are using this as the determinant of A. Then this times, this quantity times, what we are doing is, first we are interchanging the diagonal elements. 3 and 2 are interchanged, then 2 comes here and 3 goes here. Then this -1 and -2 or the remaining elements has to be multiplied with negative sign. This would be minus into -1, then minus into -2. Now we have already identified and value for this module, this determinant of A. Then A inverse can be obtained as determinant of A. It has already obtained as 4. Then we can do this scalar multiplication of matrix. Therefore, A inverse is obtained as 2 into 1/4 gives the value as half, 1 into 1/4, then 2 into 1/4, again this is half, then 3 into 1/4, we'll get this as 3. And this can be considered as inverse for this given 2 by 2 matrix. And then I will consider another example on this. If I take the next example, I will take the last example here given as this D. Here we can see that 4, 3, 8, and 6. If you ask to calculate the value for D inverse, first we need to check whether D inverse exists or not. To check whether D inverse exists or not, first we need to take the determinant of D, determinant of matrix D. To take the determinant of matrix D, you can take the difference of the product of the diagonal elements, then 4 times 6 minus 8 times 3, it is 24. Now you can see that D equals 0. Rather than saying like this, we will say it as, since determinant of D equals 0, D inverse does not exist. Therefore, since we can say that D inverse does not exist, it is because at this point we have obtained that determinant of D is equal to 0. It is because if you try to find out the determinant, this D inverse value, then you will get this as 1 over 0 times, if I continue the calculation, for here it is -3, -8. Now this goes to infinity. That is why we are saying that D inverse does not exist. No need to perform this calculation at this point. Actually, at this point, we can stop our calculation. No need to continue this part. This is why we can say that D inverse does not exist. And for any other higher order, it means that for any other n by n square matrix, we can obtain the inverse by, suppose that A is an n by n matrix, then A inverse can be obtained as the adjoint of this matrix divided by the determinant of the given matrix. Therefore, A inverse is obtained as the adjoint of the matrix divided by the determinant of the matrix. This is all what I need to discuss in this session, and thank you all for participating with this session.